Hello grade 10 students, welcome back. I am Madhu Varke and this is video lesson number 2. In the previous video class, we started with chapter 3, pair of linear equations in two variables, and we learned how to solve a pair of equation by graphical method. In this section, we will establish the conditions for consistency. What do we mean by condition for consistency? These are those conditions which tell us whether a given pair of equation will have solution or not, even without solving them. These conditions are based on the ratio of coefficients of variable x, that is a1 upon a2, ratio of coefficients of y, b1 upon b2, and ratio of constants, that is c1 upon c2. If a1 upon a2 is not equal to b1 upon b2, then the pair of equations represent intersecting lines and they will have exactly one solution. Saw this in the pair of equations that we obtained for word problem 1 that we solved in previous class. a1 upon a2 is equal to 1 on 1, b1 upon b2 is equal to minus 7 on 3, minus 3, which is 7 on 3, and you can see that these two ratios are not equal. Hence, the graphical representation of this pair was intersecting lines and it had a unique solution. If the ratio a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then the pair of equations will have infinitely many solutions, as on the graph they will represent coincident lines. Look at the second equation. If we find out a1 upon a2, it is 3 on 1, b1 upon b2 is 6 on 2. On reducing, this becomes 3 on 1, and c1 upon c2 is 3900 upon 1300, which on reducing is also 3 on 1. All these ratios are equal, and hence when these lines were represented on the graph, they gave us coincident lines and infinite solution. The third condition is a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. The third word problem gave us these equations. Let's check the ratios. In a1 upon a2 is equal to 2 on 4. On reducing, it is 1 upon 2. b1 upon b2 is equal to 1 on 2, and c1 upon c2 is equal to 160 on 300. On reducing, c1 upon c2 will become 8 on 15. So you can see that in this third example, the three ratios a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, and we plotted these equations on the graph. They gave us coincident lines and no solution. Now this is true for all equations. So before solving, we must use these conditions to find out if the pair of linear equation has solution or not. And we will solve only if the first condition is met. However, if a question is asking you to represent a pair of equations on the graph, irrespective of whether it has solution or not, the equations must be represented on the graph. The equations that give us solution or many solutions are said to be consistent. and this equation here that has no solution is said to be inconsistent. With this knowledge, let us now do this problem. Given the linear equation 2x plus 3y minus 8 equal to 0, write another linear equation in two variables such that the geometrical representation of the two equations is intersecting lines, parallel lines, and coincident lines. So let's take the first one. One of the equations of the pair is given 2x plus 3y minus 8 equal to 0. To have unique solutions, a1 upon a2 should not be equal to b1 upon b2. So choose values of a2 and b2 and form an equation such that this condition is met. So you can choose any random numbers, 3x, say 3x plus y minus 2 equal to 0. Now find the ratios a1 upon a2 of the two equation. a1 upon a2 is 2 on 3, b1 upon b2 is 3 on 1. This implies a1 upon a2 is not equal to b1 upon b2, and hence these two equations have unique solution. Now let's find an equation that gives us parallel line with the given equation. The condition for parallel lines is a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2. Our equation is 2x plus 3y minus 8 equal to 0. So in order to have the first two ratios same, you can multiply the terms having x and y with the same factor. Say we multiply 2x plus 3y with 2, so you get 4x plus 6y. Now the constant needs to be a different constant so that you don't get the same ratio. So let the constant be minus 1. Now check the ratios. a1 upon a2 is 1 on 2, b1 upon b2 is 3 on 6, which gives us 1 on 2, and c1 upon c2 is minus 8 on minus 1, which is 8. So we have chosen values of a2, b2 and c2 in such a way that it satisfies the condition. So this is our equation. You can write as many equations as you want by choosing appropriate values to satisfy this condition. Now let's find an equation so that we get coincident lines. To get coincident lines, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. All three ratios must be equal. So the equation we have is 2x plus 3y minus 8 equal to 0. What we can do is multiply this equation, complete equation, by some factor, say 3. So we get 6x plus 9y minus 24 equal to 0. Now compare the ratios of these two equations. This is our first equation. So a1 upon a2 is 2 on 6, which is 1 on 3. b1 upon b2 is 3 on 9, which is again 1 on 3. c1 upon c2 is minus 8 on minus 24, which is 1 on 3. So all three ratios are equal, therefore our equation is correct. Let us do this problem now. Half the perimeter of a rectangular garden whose length is 4 meters more than its width is 36 meters. Find the dimensions of the garden. The dimensions of the garden are the length and the breadth of the garden. So let the length of the garden be x meters and width of the garden be y meters. Break the question into parts in order to extract the equation. The length is 4 meters more than its width. So the length is x. Length is equal to 4 meters more than its width. Gives us the first equation. So x minus y is equal to 4 is our first equation in the standard form. To get the second equation, read the remaining part of the question. Half the perimeter. Perimeter of a rectangle is given by 2 times length plus breadth. So half the perimeter will be p upon 2 equal to length plus breadth, and it is given that half the perimeter is 36. So that is equal to x plus y. So we have our second equation. Now solving these two equations by graphical method, we need to find the points to plot. So to do that, we will first write y in terms of x. So y is equal to, keeping y on one side and taking all other terms to the other side, y is equal to x minus 4. And then we find out the points. So draw the table. X, y. Let's take value of x as 4. Then 4 minus 4 becomes 0. So value of y is 0. Let's take multiples of 4. So let the next value of x be 8. Value of y will be 4. So x increases by 4. So adding 4, we get the next number as 12. Y also increases by 4. So the next number here will be 8. Similarly, let's find out the points for the other equation. Y in terms of x will be 36 minus x. Finding points. Let's say x is 16. So when we substitute x as 16, y is 20. If x is 18, y will be 18. If x is 20, y will be 16. Now in your textbook, for graphical solution, only 2 points have been calculated. But it is always better to show 3 points on the graph. Why? Because if you show just 2 points, suppose you have just 2 points, these two, and if one of them is wrong, say this point is wrong by calculation error, then you have just 1 point which is correct, and through 1 point infinite lines can pass. Which means if you have drawn a line, say these two are your 2 points on the graph, and you have drawn a line passing through these 2 points, out of which 1 point is right and the other is wrong. There is no way of knowing that this line is wrong. But if you have a third point also, say this point is right, this point is wrong, and this point is right, you can clearly notice that you cannot draw a line through these 3 points if one of your points is wrong. Having said that, let's start plotting the equations on the graph. Divide the graph paper by drawing x and y axis. Our points are all positive, so it is enough to show only the first quadrant. Also look at the range of numbers in the table of points. X varies from 0 to 20 and y varies from 0 to 20. So choose an appropriate scale like 2 centimeters equal to 4 units on x-axis, and on y-axis also you can choose the same scale, 2 centimeters equal to 4 units. Plotting the first point of the first equation, it is 4, 0. It will lie on the x-axis. Then the next point is 8, 4 and 12, 8. We get 3 points lying on a straight line, so let's join them. Don't forget to mark the arrows and label your line before going on to the next equation. Whenever plotting, always choose another ink to show the second line. Join these points and label line with the corresponding equation. The lines are intersecting. The point of intersection is 20, 16, and this is the solution of this pair of linear equation. Now let's plot the given set of equation on the graph and determine the coordinates of vertices of the triangle formed by these two lines and the x-axis, and shade the triangular region. Arrange the terms of the equation and rewrite y in terms of x. So y equal to x plus 1. Let's find the points. If you take x as 1, then y becomes 2. It's an easy equation to work with. If x is 2, y is 3. X increases by 1 and so does y. Rearrange the second equation. We get 2y equal to 12 minus 3x. Therefore, y is equal to 12 minus 3x upon 2. Draw the table to find out the points. If we take x as 0, then the numerator becomes 12, so y is 6. Taking x as 2, the numerator becomes 6, so 6 divided by 2 will give us 3. There is an increase of 2 in the value of x, so next number can be 4. So y decreases by 3. To get the next number, minus 3 from 3, you get your y value. Now let's plot these points on the graph. If you look at the x values of both the equations, the numbers range from 0 to 4, and the y values range from 0 to 6. So divide the axis in such a way that all these numbers are accommodated. So we can take 2 centimeters as 1 unit on the x-axis. Same on the y-axis, we can take 2 centimeters as 1 unit. The first equation is y equal to x plus 1. So let's start plotting the points. The first point is 1, 2. Second point 2, 3. And third point is 3, 4. Before plotting the second equation, finish joining these points by drawing a line. Label the line with the corresponding equation. 0, 6 will lie on the y-axis, 2, 3 and is the second point, and 4, 0 will lie on the x-axis. Passing a line through these 3 points, we get the point of intersection. You can read the point of intersection from the graph. It is 2, 3. So the x value is 2 and y value is 3. Now the second part of the equation is asking to shade the triangular region. The two lines and the x-axis form triangle ACB. So triangle ACB is the required triangle to be shaded. If in case the question asks you to shade the triangle formed by two lines with the y-axis, then the green triangle is the required triangle. So far in the chapter, we have studied the graphical method of finding a solution to a pair of equations. There are more methods like substitution, elimination, and cross multiplication, which we will study in the next video lesson. At the end of the chapter, we have some complex pair of linear equations into variables which need to be reduced in their standard form before applying these methods. That is all in today's video lesson. I will leave you with this assignment, exercise 3.2, question number 2, 3 and 4, to be done in your notebooks neatly. We shall meet in the next class with new concept. Till then, goodbye.